The 100,000-ton warship, longer than 3 football fields, has finally returned to the water after years of waiting. The USS Gerald R. Ford, America's most advanced and expensive aircraft carrier ever built, has completed a major 15-month repair period inside one of the world's largest dry docks. This $13 billion floating fortress is now back in action, ready to project American power across the world's oceans once again. Moving a ship of this size is an incredible engineering challenge. So what caused this massive supercarrier to require such extensive repairs? And why is this vessel so important that the U.S. Navy could not afford to keep it out of service for long? Stay with us. The USS Gerald R. Ford is not just another aircraft carrier. It represents the beginning of a new era of American naval power. Built as the first ship of the Ford-class carrier program, it was designed to deliver unmatched combat capability and maintain U.S. dominance at sea. When this massive warship entered dry dock for major repairs and upgrades, it became a critical moment for the Navy. The Ford-class carriers are equipped with revolutionary technology that no other country currently operates, including electromagnetic aircraft launch systems, advanced arresting gear, and next-generation radar systems. These innovations push the limits of modern naval engineering. But with groundbreaking technology comes complex challenges. For more than a year, over 1,000 workers worked around the clock to repair, improve, and upgrade the carrier's most important systems. This enormous floating fortress carries around 4,500 sailors and can operate with an air wing of approximately 75 aircraft, making it one of the most powerful warships ever created. If you appreciate the dedication and technology behind the U.S. Navy, share your thoughts in the comments below. Today we're diving deep into exactly what happened, why these repairs were so critical, and what they mean for America's naval dominance. The power of the USS Gerald R. Ford. Let's begin by understanding what makes the USS Gerald R. Ford such an important asset to the U.S. Navy. This is not just the Navy's newest aircraft carrier. It is the most technologically advanced warship ever constructed, stretching over 1,100 feet long and weighing around 100,000 tons when fully loaded. The Ford-class carrier is an absolute giant, but its true power goes far beyond its size. The Ford-class carriers can generate nearly 3 times more electrical power than the older Nimitz-class carriers. This enormous energy capacity is not just for show. It allows the ship to operate the Electromagnetic Aircraft Launch System, or EMALS, replacing the traditional steam catapults used for decades. These advanced launch systems can send aircraft into the sky more smoothly, more frequently, and with greater precision. Pilots experience less physical stress, while aircraft receive less structural damage over time. The USS Gerald R. Ford can support up to 270 aircraft sorties per day, around 33% more than previous carrier classes during combat operations. That increased capability could become the difference between success and failure in a major conflict. More sorties mean more strike missions, more intelligence operations, and stronger air superiority. The Ford provides commanders with a level of operational flexibility that few, if any, naval forces in the world can match. But here's something many people don't realize. Despite being far more advanced, the Ford-class carrier requires around 600 fewer sailors compared to a Nimitz-class carrier. Advanced automation systems now handle many tasks that once required large numbers of crew members. This reduces personnel demands, saves operating costs, and decreases the pressure on living spaces, food supplies, and life support systems. Every part of the ship was designed to maximize efficiency and combat capability. The carrier is also equipped with advanced radar technology, including the AN/SPY-3 multifunction radar and the AN/SPY 4-volume search radar. Together, they create a powerful dual-band radar system capable of tracking hundreds of targets at the same time, while supporting missile guidance and coordinating aircraft operations. With the Ford-class carrier on patrol, approaching threats can be detected earlier, tracked faster, and engaged more effectively than ever before. Why the Ford needed emergency repairs. So what actually went wrong? Why did this masterpiece of modern naval engineering require such major repairs so early in its service life? The problems first appeared during post-delivery sea trials in early 2018. The USS Gerald R. Ford was operating at sea, undergoing critical testing, when alarms suddenly began sounding inside the engineering spaces. One of the ship's main thrust bearings, a massive component responsible for transferring power from the nuclear reactors to the propeller shafts, had failed. This was not a simple mechanical issue. If the problem had continued, the damaged bearing could have caused severe and potentially catastrophic damage to the entire propulsion system. The main thrust bearing is one of 4 critical components designed to handle the enormous forces produced by the carrier's nuclear power plant. Each bearing must endure extreme heat, pressure, and rotational stress, while keeping the massive shaft system operating smoothly. When one of these bearings fails, the entire propulsion system is placed at risk. The Ford was forced to shut down affected systems and carefully return to port using limited power while engineers investigated the failure. The investigation discovered that the problem came from manufacturing defects during the machining process. The faulty bearing had been produced with errors that created weaknesses, causing it to fail under real operational conditions. This was a major concern because thrust bearings are not ordinary replacement parts. They are enormous, highly specialized components that cannot simply be removed and replaced overnight. Huntington Ingalls Industries, the shipbuilder responsible for constructing the Ford, was tasked with repairing the damaged system. The Navy provided funding immediately because the situation was urgent. The United States needed its newest aircraft carrier back in service. The repair process required moving the entire 100,000-ton carrier into dry dock, one of the most complex and expensive procedures in naval maintenance. And the timing made the situation even more critical. When the Ford encountered these problems, the U.S. Navy's carrier fleet was already under heavy demand, with operations and commitments across the Mediterranean, Persian Gulf, and Western Pacific. Having one of America's most advanced carriers unavailable created serious operational challenges. However, the Navy had no choice. It was far better to repair the problem completely during maintenance than risk a catastrophic failure during an actual combat mission. The dry dock process. Moving a 100,000-ton aircraft carrier into a dry dock is an engineering achievement by itself. You cannot simply drive a ship this massive into a garage. The entire operation requires precise planning, specialized equipment, and years of naval expertise. First, the carrier must be carefully positioned above the dry dock while the dock is still filled with water. Multiple tugboats, sometimes 6 or more, work together to guide the enormous vessel into the exact position. The accuracy required is measured in inches. If the ship is even slightly misaligned, it could damage both the carrier and the dry dock during the draining process. Once the Ford is perfectly positioned, workers install massive wooden blocks and support structures beneath the hull. These supports are placed at specific points designed by engineers to evenly distribute the ship's incredible weight. A mistake in placement could cause serious structural damage, costing hundreds of millions of dollars. Then, the draining process begins. More than 100 million gallons of water are slowly removed from the dry dock. As the water level falls, the USS Gerald R. Ford gradually settles onto the support blocks below. Throughout the process, engineers constantly monitor the ship for any signs of stress, unexpected movement, or structural problems. When the dry dock is finally empty, workers gain access to areas of the carrier that are normally underwater, including the propeller shafts, rudders, and the hull itself. These areas can now be fully inspected, repaired, and upgraded. For the Ford's damaged thrust bearing, repair crews had to carefully remove the failed component, install the replacement, and perform extensive testing to make sure everything was perfectly aligned. Even the smallest error could lead to premature wear or another serious failure. The tolerances involved are incredibly precise, measured down to thousandths of an inch. While the carrier was already out of service, the Navy used the opportunity to complete additional maintenance and upgrades. When a massive warship like the Ford is in dry dock, every possible improvement is addressed. Teams worked around the clock inspecting the hull, servicing underwater systems, and upgrading critical components. Every day the USS Gerald R. Ford spent in dry dock represented a major investment, but these repairs were necessary to ensure America's most advanced aircraft carrier could return to the fleet stronger, safer, and ready for future missions. The rolling out process. After 15 months of intensive repairs and upgrades, the moment finally arrived. The USS Gerald R. Ford was ready to leave dry dock, but returning a 100,000-ton aircraft carrier to the water is just as complex and carefully planned as bringing it in. The process begins with the most critical step, flooding the dry dock. Massive pumps reverse direction, allowing water from the James River to slowly fill the enormous dock. However, this operation is not rushed. The flooding takes several days because the forces involved are enormous. If water enters too quickly, it could damage the support structures or create dangerous currents around the ship. As the water level rises, the USS Gerald R. Ford gradually begins to lift from its support blocks and return to a floating position. Engineers constantly monitor the ship, watching for any unusual movement, uneven lifting, or signs of structural stress. The carrier must rise evenly because even a small imbalance could place extreme pressure on the hull. Every stage of the process is carefully coordinated. Once the water level reaches the same height as the surrounding river, the massive caisson, a giant watertight barrier that seals the dry dock, is removed. This finally opens the path to the outside waterway. But the Ford is not ready to simply sail away. Before leaving the dock, engineers and technicians must inspect the ship, test critical systems, and confirm that every repair has been completed successfully. Then, the tugboats return. These powerful vessels carefully push and pull the massive carrier out of the dry dock and into the main channel. Despite their strength, the movement is extremely slow and precise. The carrier is not moving miles per hour. It is moving only a few feet at a time. Every action is controlled and calculated. Watching this process is an incredible sight. A ship larger than 3 football fields, weighing around 100,000 tons, slowly emerging from a dry dock, almost looks impossible. Yet this floating fortress is designed to move across the world's oceans and project American naval power. The tugboat crews responsible for this operation are among the most skilled mariners in the world. They understand the currents, the ship's movement, and exactly how the Ford will react to every adjustment. A single mistake could damage the carrier or the dock, potentially causing hundreds of millions of dollars in damage. Once the USS Gerald R. Ford clears the dry dock, it moves to a nearby pier for the next stage: system test and certification. Floating again does not mean the carrier is immediately ready for deployment. Every repaired system must be verified, every piece of equipment tested, and the crew must complete additional training and drills before the ship returns to full operational duty. Testing and certification. After leaving the dry dock, the real challenge begins. The USS Gerald R. Ford must go through a series of rigorous tests before the Navy can officially certify it as ready for deployment. These are not simple inspections. They are full evaluations designed to prove that every major system can perform under real operational conditions. The propulsion system receives the highest level of attention because the original thrust-bearing failure was the reason the carrier entered dry dock in the first place. Engineers carefully monitor temperatures, vibrations, pressure levels, and overall performance while running the system at different power settings. The new bearings must prove they can handle the massive forces generated during full-speed operations without showing any signs of failure. The ship then conducts what the Navy calls fast cruise exercises. During this phase, the crew operates the carrier as if it were already at sea, while the ship remains secured at the pier. This allows sailors to test communications, damage control procedures, combat systems, and emergency responses in a controlled environment. If any issue appears, engineers can fix it before the ship returns to open waters. Next comes the most important phase, the sea trials. The Ford heads back into the ocean for extended testing missions. The carrier pushes its limits by reaching high speeds, performing sharp turns, stopping and accelerating repeatedly, and testing how the repaired propulsion system responds under extreme conditions. Navy officials and engineers from Huntington Ingalls Industries closely monitor every movement, making sure all repairs meet the required standards. But the propulsion system is only one part of the evaluation. The Electromagnetic Aircraft Launch System, EMALS, must also pass extensive testing. Engineers conduct dead load tests by launching heavy sleds that simulate the weight of different aircraft. These repeated launches place enormous stress on the system, proving whether it can reliably launch aircraft during real combat operations. The Advanced Arresting Gear (AAG) system receives the same level of scrutiny. This system must stop aircraft weighing up to 50,000 pounds as they land at high speeds and bring them to a complete stop within only a few hundred feet. The forces involved are massive, and even a small failure could put pilots' lives at risk. The Ford's radar, weapons, and communication systems also undergo detailed testing. The carrier must demonstrate that it can detect threats, coordinate with other ships and aircraft, engage enemy targets, and maintain reliable communication even in situations involving electronic warfare and enemy attempts to disrupt signals. Throughout the entire process, the crew is also tested. Sailors train with the ship, learning its systems, emergency procedures, and operational capabilities. They practice damage control, repairs, and combat scenarios to ensure they are ready for any situation. Because a carrier is not only a machine, it is a combination of advanced technology and the people who operate. The USS Gerald R. Ford is only as powerful as the sailors who keep it ready for battle. Here, strategic importance. The successful repair and return of the USS Gerald R. Ford carries enormous strategic importance for the United States Navy. Aircraft carriers remain one of the strongest symbols of American military power and the ability to project force anywhere in the world. When a carrier is fully operational, it provides capabilities that no other military asset can match. A single carrier strike group can influence events across hundreds of thousands of square miles, giving commanders unmatched flexibility and global reach. The presence of an American supercarrier can completely change the calculations of potential adversaries. Nations are forced to think carefully before taking aggressive actions when a Ford-class carrier is operating nearby. This concept is known as deterrence, preventing conflicts by demonstrating overwhelming strength and readiness. The advanced technology of the Ford class makes it even more valuable compared to previous generations of carriers. Its ability to launch more aircraft sorties allows it to maintain sustained combat operations for longer periods. Its reduced crew requirements help lower operational costs, while improved reliability means more time at sea and less time in maintenance. Now consider the global challenges facing the United States. China continues to expand its naval capabilities and increase pressure in disputed waters. Russia remains a major strategic competitor across multiple regions. Iran continues to threaten important international shipping routes, while North Korea remains unpredictable and dangerous. In this environment, maintaining a strong carrier presence is more important than ever. The U.S. Navy plans to eventually operate a fleet of 10 Ford-class carriers, although completing this transition will take many years. Each new carrier is designed to replace aging Nimitz-class ships, ensuring that America maintains its naval advantage as older vessels reach the end of their service life. However, the USS Gerald R. Ford serves another important purpose beyond being a powerful warship. It is also a testing platform for the next generation of naval technology. Every challenge solved, every improvement made, and every lesson learned from the Ford program helps future carriers become more advanced, more efficient, and more reliable. The Navy understands that the first ship of any new class often faces the greatest challenges, but those challenges create valuable experience for the future. Critics often question the enormous cost of these ships. A $13 billion aircraft carrier is certainly a massive investment, but what that investment creates is unlike anything else. A mobile military airbase capable of operating for months, projecting power across thousands of miles, and conducting missions without depending on foreign bases. No other military asset provides the same combination of flexibility, endurance, and global capability. America's allies also benefit from the presence of these carriers. When a U.S. carrier strike group arrives in a region, it sends a powerful message of support and commitment. This strengthens alliances, promotes stability, and reinforces the international security system that has helped prevent large-scale conflicts since World War II. The USS Gerald R. Ford is more than just a warship. It represents decades of engineering, innovation, and the commitment of thousands of sailors, workers, and engineers who keep it operational. Its return to service proves that even the most advanced technology can face challenges, but with expertise, determination, and resources, those challenges can be overcome. The Ford class represents the future of American naval power, a combination of advanced technology, unmatched capability, and the ability to project strength anywhere on the planet. The human element behind the technology. Behind all the advanced technology and incredible statistics, there are thousands of dedicated Americans who make the USS Gerald R. Ford possible. The sailors who operate the carrier, the shipyard workers who carried out the repairs, and the engineers who designed its systems all deserve recognition for their skill, dedication, and commitment. The shipyard team spent more than 800,000 man-hours working on the thrust-bearing repairs alone. Think about the scale of that effort. These highly trained workers operated in challenging conditions, often inside narrow and complex spaces, knowing that their work directly affected national security. Every weld, every measurement, and every inspection had to be completed with absolute precision. Their professionalism and attention to detail ensured that the repairs were completed correctly and safely. Throughout the repair period, the Ford's crew never stopped preparing for the mission ahead. Even while the ship remained inside dry dock, sailors continued training, studying procedures, and improving their skills so they would be ready the moment the carrier returned to the ocean. Their commitment never faded. Navy leadership also played a critical role by making difficult decisions. Removing a carrier from active service creates operational challenges and requires significant resources. However, leaders understood that rushing the process or ignoring problems would only create greater risks in the future. They chose to fix the issues properly, even when the decision was difficult. This entire experience highlights an important part of American military capability. New technologies can face unexpected challenges, but the United States has the industrial strength, engineering expertise, and resources needed to overcome them. America learns, adapts, and continues moving forward stronger than before. The return of the USS Gerald R. Ford represents more than just one aircraft carrier becoming operational again. It represents American determination, innovation, and the commitment to maintaining a powerful and capable Navy. It sends a message to allies around the world that they can rely on American support while reminding potential adversaries that the U.S. Navy remains one of the most advanced maritime forces on Earth. As the Ford prepares for future deployments, this incredible warship carries the dedication of thousands of people who built, repaired, and operate it. This massive vessel and its crew will continue sailing across the world's oceans, protecting American interests and supporting global stability through strength and readiness. Outro. The story of the USS Gerald R. Ford's repair and return to service represents the best of American engineering, military capability, and human dedication. From the skilled shipyard workers who completed one of the most complex naval repairs ever attempted, to the sailors who continued training and preparing throughout the process, everyone involved showed incredible professionalism and commitment. This $13 billion supercarrier is now ready to return to its mission. The repairs are complete, the systems have been tested, and the USS Gerald R. Ford is prepared to operate at the forefront of naval power for decades to come. If you enjoyed this deep dive into one of the world's most advanced warships, don't forget to like this video and subscribe for more detailed military stories and technology breakdowns. Your support helps us continue bringing you more incredible stories from the world of defense and naval engineering. The USS Gerald R. Ford is back at sea, a powerful symbol of American innovation, strength, and the dedication of everyone who keeps it operating.